Hi all, wanted to start out today by reviewing these warm-up questions because last lecture and this one and the next really all run together quite a bit and are very important in this unit, and so want to take time to make sure that we're getting these underlying ideas right. So for number one, why do we have to balance chemical equations? We have to balance chemical equations because the law of conservation of matter and mass tells us we cannot create or destroy matter. It's a very important underlying kind of universal law, and we have to therefore start and end with the same number of atoms. If you remember from last semester, a chemical reaction is where the atoms are changing how they're connected to each other. And so the connections change. We have to start and end with the same number of atoms. Number two, in this example, 5 is the coefficient. That 5 is telling us that we have 5 of the molecule. In this case, the molecule is made up of 2 hydrogens connected to 3 oxygens. Those are subscripts. Subscripts tell us how many of each type. Coefficients tell us how many of that group, how many of that molecule. For number 3, if we look at that equation, we can see that aluminum and oxygen are kind of independent, more independent on the reactant side, and then are smushed together, technical term there, in the product side, and they've made aluminum oxide. And so this is a synthesis, where we're taking pieces and putting them together. It's also a combustion, but for our class, we're focusing on the aspect of it being a synthesis. Is the reaction balanced or unbalanced? It is unbalanced because we have 1 aluminum on the left and 2 aluminums on the right. We have 2 oxygen atoms on the left and 3 oxygen atoms on the right. So as we are going from the left, our reactant side, to the right, our product side, the number of atoms is changing, and we can't have that. Number 5, how would you balance it? Well, that is actually going to be what we're doing next, so I'm going to go ahead and save that example for the other ones that we're going to do in just a minute. And because I think I'm oh so funny, did you miss the mole? If you did, well, the mole is coming back, and that's awesome. If you didn't, don't panic. I promise it's actually probably easier for most of y'all this semester with the mole, which is exciting, but you all know that I think the mole is just great. So let's go ahead and work now on our summary sheet. The vocabulary here is what we're adding. This vocabulary is going into those 5 goals that you wrote down last class. Our coefficient, that's that number in front of the formula and indicates how many molecules, 4 moles. That's where the mole is coming back in of that compound are needed. The molar ratio, that sounds hard, but what it means is that when you have balanced an equation, these numbers are telling us that I need 2 moles of hydrogen, and that I need 1 mole of oxygen, and I need 2 moles of water. And so molar ratio is you take any of those statements that are made true by it being a balanced equation and set them equal to each other. So in this case, there are only 3 possible ratios that we could say. And I wrote all those to the side and then also wrote them as a conversion factor. If you remember from last semester, if you have 2 moles of hydrogen are needed for, so are equal to 1 mole of oxygen gas, right? O2. You can write that as a conversion factor where you stack them over each other, and that's really how we use this relationship later on. And so we're going to be practicing identifying molar ratios in our homework. So I want to introduce that idea kind of early here. All right, we're going to move to the balancing practice. So go ahead and please write down that first equation on your notes. If you need to pause to do that, you can. I'm going to expand the video in the corner here. I want to apologize for the fact you're going to get kind of a close-up on the banged up hand from Wednesday. I don't know if anyone else kind of fell in the ice, but that happens. So, alright, so our first equation there was we have, S8 as a molecule, we have O2 as a molecule. Those two are getting smushed together and making SO2. So this is a synthesis, again. let's go ahead and start doing our balancing. The first step in balancing is do an atom inventory and see if it's already balanced. It's kind of nice when it is. On my reactant side, I have 8 sulfurs and I have 2 oxygen. On my product side, I have 1 sulfur and 2 oxygen. So unfortunately, it looks like it's not balanced. Second step in balancing is start somewhere, right? I generally recommend not starting with hydrogen and oxygen, and other than that, most of the time it doesn't matter too much. So we're going to go ahead and start with sulfur because that's the only thing that's unbalanced. The only coefficient that I can put here that's going to work to make it so I have 8 sulfurs is 8, because 8 times 1 is going to be 8. If I have 8 of this molecule and each molecule has 1 sulfur in it, I now have 8 of that atom in the product. Well, unfortunately, when we have a coefficient in front, that coefficient operates on the molecule as a whole. It is not just limited to the one that is convenient for us that we want it to kind of work on. It's going to apply to the molecule here as a whole. And so I have 8 sulfurs, and I also have 8 of these O2s that are in the molecule, so 8 times 2 is 16. And I call this the thread. When you are changing this on purpose and then something else changes and you're like, what the heck? To me, that's the thread, and that's the thing that we kind of have to chase, and it tends to bring us full circle and fixes some of the things that are going on. So let's go ahead and pull on that thread here, and we're going to stick with this oxygen thing that just changed. So we're going to try and make oxygen balance now. I've got 16 oxygens in the product. I want 16 in the reactant, so I'm going to put an 8 here, because 8 times 2 is 16. And that's 16 there. And now when I look at it, I can see that I have 8 sulfurs starting and ending, and I have 16 oxygens starting and ending. So this is now balanced. Yay! Let's go ahead and move on to the next one. Aluminum and oxygen, creating aluminum oxide. This is another synthesis example where we have 2 molecules combining to make 1. Let's go ahead and try our first step, which is again doing our atom inventory. I have 1 aluminum, I have 2 oxygens in my reactant. I've got 2 aluminums and I've got 3 oxygens in my product. I will say it's very easy to accidentally put a number in the wrong spot here if you're a little bit distracted. So, you know, if you're trying to balance something and it's just not working out, it's always okay to erase it, you know, and just start fresh on it. So sometimes that happens. And that's why that homework last class was just practicing counting, because if our count is off, it makes the balancing tough to impossible. So let's go ahead and look here. We need to get the aluminum balance, we need to get the oxygen to balance. We can start either place. I do generally recommend not starting with oxygen or hydrogen. In this case, it probably wouldn't really matter. But let's go ahead and follow that kind of pattern anyway. I want to make the aluminum match up, so I put a 2 in front of the aluminum on the reactant, and now we have 2 aluminum and 2 aluminums. Great. If I look here, 2 and 3, there's no whole number that I can multiply by that's going to make these two, like this 2 be 3. There's no whole number I can multiply 2 by to make it equal to 3. And coefficients are always multiplying, so I'm going to have to get both of these to a number they have in common. The number they have in common is 6, so I want to get them both to 6, so let's try that. I'm going to put a 3 in front because that's going to get us to 6 here, because 3 times 2 is 6. And then I want to get 6 over here, so let's go ahead and put a 2 in front here, and that gets us 6 oxygen as well. Because 2 times 3 oxygen in each of those molecules gives us 6 oxygen atoms. And there's our thread. I didn't plan on this one changing. This is the unintended side effect that kind of stinks and throws up all the plans for a little bit. But we're gonna follow the path here, and it's gonna bring us around. So the 2 we already updated our oxygen, we're going to update our aluminum. 2 times 2, well, that's 4. And now this is the part that's not balanced. This is our thread that we need to finish off. So let's balance the aluminum. I'm going to come back to the aluminum on the reactant side and scribble out that coefficient for a moment. I should have maybe not used pen, huh? But we're going to put a 4 there. And what do you know? We got it. 4 times 1 is 4, so that's good. 3 times 2, we've got 6. At 2 times 2, we have 4. 2 times 3, we have 6. I start and end with 4 aluminum. I start and end with 6 oxygen, and it's balanced. So I'm going to go ahead and minimize this again for a moment, move it a little bit up here so it's a little more out of the way. Go ahead and pause for a moment and see if you can do those next 3 problems on your own, and I will come back and run through them in just a moment. Alright, let's run through these. So, the next problem was that we had silver oxide breaking into silver and oxygen. This is a decomposition reaction. My tally is right here, and you can see that starting off, it is not balanced. I want to go ahead and balance the silver first, the Ag, so I'm going to put a 2 in front, and that balances that out. And then I want to balance this out, so I need to do something to the reactant side. I put a 2 in front there, and now I have 2 oxygens, but it fixed my oxygen and it messed up the silver. So let's go ahead and update that silver, and now come back following that thread, that thing that changed that we didn't want. We're going to come over here and update that and fix it, and we've got a balanced equation. So for this, you can leave these blank or you can put a 1 in, whatever kind of makes more sense to you. 2 moles of silver oxide will break into 4 moles of silver and 1 mole of oxygen. For this problem, we've got methane and chlorine gas producing tetrachlorocarbide, not sure about that, plus hydrogen gas. And we're going to go ahead and run through this here. I've got 1 of each carbon, got 2 chlorines and 4 chlorines, and I've got 4 hydrogens to 2 hydrogens, so we can see it's not balanced. I will say that this would have been easy to accidentally flip, so again, just trying to be careful when you're putting those numbers in that you're putting them in the right spot. This is a single replacement reaction. You can see that at the beginning, carbon is bound to several hydrogens, and chlorine is sort of by itself in a diatomic molecule, and then the chlorine has replaced the hydrogen, and hydrogen is now the diatomic element, so molecule. So that is a single replacement reaction. Let's go ahead and start balancing. I'm going to start with chlorine. I could start with something else, that would also be fine, but to get going, just got to pick somewhere. So I'm going to go ahead and put a 2 in front of the chlorine. 2 times 2 is 4. These 2 are now even. Hooray! Alright, well, nothing unexpected here. The only atom type was chlorine, and chlorine got updated, so now I need to pick somewhere else to go try. Hydrogen is unbalanced. I need more hydrogen in my product. I put a 2 in front. Oops, sorry. 2 times 2 is 4. I have 4, and look at that. We're balanced. Which is really nice. Sometimes it's nice we get kind of a pleasant surprise, and we get one that's a little bit simpler where we're not having to go back and fix anything again after. So I'm going to go ahead and call it here and move into the next video to do that last example and connect this back to the mole. Great work so far. See you in a sec.